Hello. In this video, we will try to find out inverse of a rational function. Many students have been struggling to do that, and let's see how we can really do it. What is a rational function? The rational function normally is written as a ratio of two polynomial functions, where we can write numerator as one polynomial and denominator as the other polynomial. Here, the condition is that the denominator is not equal to 0, because you can't divide by 0. It is indeterminate and it's not possible. Therefore, we have this as a restriction. So, rational functions will always have a restriction. Sometimes they may not have, but most of the time they will have restriction. So, whenever we are given a rational function, first thing is to find what the restriction is. Easiest way to do it is take the denominator, equate it to 0, and that point which makes it 0 is not in the domain of our rational function. Now let's take an example of a function and try to find out its inverse. Let's say the function is x plus 1 over x minus 1. This is a very simple rational function. In here, what is the restriction? The denominator qx is x minus 1. So we should say x minus 1 should not be equal to 0. That means x cannot be equal to 1. So basically, x belongs to real numbers, but x is not equal to 1. This is what we are trying to say when we write comma, x is not equal to 1. Remember, if the set of numbers is not mentioned, set of real numbers is our default value. Okay? So the domain is always a set of real numbers if not specified. Now let's try to find out inverse of this function. Okay? Now to do inverse, what are the steps? First is replace fx with y. Let's do that. So we get y equals to x plus 1 over x minus 1. Step number 2, swap x and y. So let's do that. We'll write here x and y there. So we get x equal to y plus 1 over y minus 1. Now what is the next step? Simple. Solve for y. And that will give us the inverse. How to solve for y here? The easiest way is multiply both sides by y minus 1. Okay? So if you do that, let me show you here. If we times by y minus 1 here and y minus 1 here, then these gets cancelled out. Do you see that? And you get x times y minus 1 equals to y plus 1. This is what we are going to do. So we'll write this as x times y minus 1 equals to y plus 1. So sometimes we call this operation as a cross multiply. Think the denominator of x is 1. So you multiply y plus 1 with 1, you get the same thing as y plus 1, and multiply x with y minus 1. So cross multiply also gives us the same result as we got for by multiplying by same factors on both the sides. Okay? Now we will expand it. Apply distributive law. So when you multiply, you get xy minus x equals to y plus 1. Now bring the y terms on your left, because you want to find what y is in terms of x or anything else, and bring x term on that. This has both x and y terms. We'll keep it here. X times y minus y equals to, bring it on that side, it becomes plus x plus 1. Now in here we have y common, right? Factor y out. When we factor the y out, we get x from here minus 1 equals to x plus 1. And now what y is? You can divide by x minus 1 both sides. Y is equal to x plus 1 over x minus 1. So now the last step is we got the inverse, correct? Write it in function notation. Replace y with f inverse. So f inverse of x is equal to x plus 1 over x minus 1. In this particular example, you saw what was the function? Remember, the function is x plus 1 over x minus 1. And what is the inverse of this function? F inverse of x is x plus 1 over x minus 1. This particular function is also inverse of itself. Do you see that? Well, by going through these steps, we can solve any rational function. You can try on your own some examples, like try this. Gx equals to 2x minus 1 over x plus 3. So what will you do? First step, write gx as y. Second, swap x and y. Then cross multiply. And then bring y terms to one side. Take y common and solve for it. That's how you find an inverse of a rational function. I hope you understand the technique. Try it, and if there is a difficulty, you can put the comments and then we'll get back to it. Okay? Thank you.